Alright, hello everyone, my name is Viraj. I am going to be your tech team co-director this year. I'm recording the last two Arduino videos for the fundamentals, so that's going to be lesson 4 and lesson 5. Today we're going to be getting into introducing structs and the sort of aspect of structs and functions just to make your life easier in C++ programming. And to introduce the concept, we're going to introduce a new hardware component called the RGB LED. Now, so far the LEDs that we've been using in a lot of our projects have been these LEDs, and they're pretty cool. So you'll see that they have a cathode and anode, or a positive and a negative. Um, and you can change the color of the shell on the outside to change what color the LED looks like. But there's actually a more sort of basic principle, not a basic, but a different principle that we can approach to have multicolor LEDs. And that's going to be the RGB LED in and of itself. The screen that you're actually looking at this video on probably uses RGB LEDs, just millions of them together. And the way an RGB LED works is that it splits the light into 3 channels, red, green, and blue, or RGB, red, green, blue. And so here's a little diagram that sort of shows off this almost color wheel or this color cycle based off of these RGB values. So we start with R as the first one, G is the second one, and B is the last one. So we'll see that if R is 255, which is the highest possible value of a short or an 8-bit integer, then that's going to be full red. Whereas if it's 255 for just the green and the other two values are 0, it's going to be just this green. And then if it's 00255, it's just blue, like this. And so you'll see that if we do red and blue at max, we'll get this purplish color. If we do red and green at max, we'll get this yellowish color. And if we do green and blue at max, we'll get the cyan, and all of them at max will get white. If all of them are 0, the LED will just be off because no power is going to it. And another system, if you're familiar with sort of graphic design, or if you use Canva, or if you just like color science, will be these HTML hex codes. You'll see that if you actually go through this board over here, the hex codes are basically just a way that we encode these RGB values inside of these numbers over here. And so these numbers are in hexadecimal. And so if you sort of calculate it, 16 to the power of 2 is 256. And so you can use just 2 hexadecimal characters to represent one of these RGB values. And so if you use 3 pairs of those 2, you'll have 6 values over here that correspond to these values over here, which is pretty cool. And so beyond that, we're going to be sort of wiring this up, and we're going to learn how to use it. And so because we're sending a variable signal, you'll see over here we have 39 in the red, we want a way to sort of send a variable signal. So not just either on or off, we want to send something in the middle, and so that's why we're going to be using PWM, or analog write, on our Arduino to send a certain signal or a certain level of power to the red, or a certain level of power to the blue, or a certain level of power to the green. And so let's get that configured. Because we're using PWM, we need to use PWM enabled pins. So obviously we'll just use 11, 10, and 9 because they're right next to each other, makes our lives easier. So we'll connect 11 to this R channel. Just move this over here, and so that much, sorry, not that much, just about this much. And we'll get this to be the red color, and then let's move this over here, so boom, and then blue, boom. And for the blue, we'll just change the color to be blue. And then let's just get our ground or a common set up, and so this is our common signal. Now, the walkthrough simulator that we're using is a little bit weird because their RGB LEDs are pre-configured to get this common pin as positive. But in most real-life situations, these RGB LEDs that you get will have the common signal as a ground. So we're going to do a little bit of inner workings, and we're going to change this to match what we want. So what we're going to do is we're going to go into our diagram.json, and you'll see that in this part section, we'll see a part called the RGB LED, and in the attributes, what you're going to do is you're just very going to simply set the common pin to be a cathode or a negative. And this is just one of the configurations we have to make. Don't worry too much about it. If you have any questions about that, please do ask on the Discord, but that should set it up. Next, we're going to sort of set up our pins over here. So we're going to call this our R pin equals 11, and then our G pin equals 10. And then our B pin equals 9. And so these are going to be the pins that we're going to be using for our, RGB LED. So let's make sure we set them up to be outputs. So pin mode, pin, output, pin mode, B pin, always do RBG, so I apologize if I do that in the middle. And finally, for our sort of loop, we just want to set these up to display a signal. Now, I'm a big fan of the color purple, so I'll just set the color purple up. And so we're going to do analog, right, and we're going to set our R pin to be the max value of 255. We're going to set our G pin to be 0 because we don't want any green, and then we're going to set our blue pin to be 255. And you'll see that once we run this, our LED should hopefully turn this purple color, which is really cool. So we've configured a color onto our RGB. Now let's say I wanted to sort of swap between a few colors. Let's find some colors that we like on this chart. Let's say we want to go through the colors of the rainbow. So red, green, no wait, what is it? Roy G. Biv. So red, orange, yellow, green, blue, indigo, violet, or something of that order. Now, actually programming that into the Arduino is going to be really tedious. So we'd have to create like a delay for 1,000 seconds, and then we'd have to write all these 3 lines over and over again. So we want to find a way to sort of condense those 3 lines of code into a simple way of explaining it, or a simple way of sort of repeating it that we can just do it again without having to write those 3 lines of code, a shorthand, if you will. And so in the shorthand, what we can do is we can make our own functions, actually. And so that's exactly what we're going to do. So you'll see that this loop function over here, loop, the way that it works is we have the return type. So what is it returning? If we're returning the void, well, the void is nothingness. So we're going to be returning nothing. And then we have the name of the function, and then we have these 2 brackets. We don't know what those 2 brackets do. And then we have these curly braces where we write our code on the inside. And that's basically the simple syntax of a function. First, you write the return type. So if we're writing, or if we're turning on an LED, we don't really want to return anything, so we're going to return the void. And then, so we're going to return the void, we're going to return nothing. And we'll just say this as set color. We'll set the color of the LED. And then we need these 2 brackets, but what goes inside of these brackets? Inside of these brackets, actually, we're going to add something called the parameter. And so if you look at the way that we write this delay function over here, we'll see that inside of these brackets we write how long we want to delay it. It's a parameter to the function. And inside of analog write, we first write what pin we want to send the signal to, and then we write what the signal is supposed to be. And so a parameter is basically something that goes into a function that changes depending on how you call it. It's almost like, sure you have a tool, but what exactly you're going to be using with that tool, right? Like I can have a knife, but with that knife I can cut an onion, I can cut a carrot, I can cut a human finger. There are a lot of things I can cut with a knife, but I need to set that as a parameter inside of my function so I can access it whenever I want to. And so the way that we're going to do that inside of our code is we're first going to write what type of variable we're dealing with. And so because we're setting our color, first we need to set our variable of what that color is supposed to be, or how much signal we want to send to that color channel. So we'll set our first variable to an int, and we'll call it red. And then we want another one for our green, and we want another one for our blue. And then now, we know that after we do that, in this function, we define a curly brace where we add all of our code. So we'll do the same thing. We'll define a curly brace and we add all of our code on the inside. And so in making this function over here, what we did is we said set color. So I want to make a function that sets the color of my sort of LED. And then I'm going to take in these 3 sort of parameters. And they're going to be red, green, and blue. And so the red parameter basically tells me how red I want it to be. The green parameter tells me how green I want it to be. And the blue parameter tells me how blue I want it to be. So before I write the code on the inside, let's see how I'm going to write the code on the outside. How do I actually incorporate this into my Arduino code? So what I'm going to do is I'm going to say set color. Same way that we access sort of the analog rate function, we're going to access the set color function. So then we open up our brackets, and now we need to add our 3 parameters on the inside. So 1, 2, 3. First is going to be our red channel. So let's find some cool color. I really like this orange tone over here. So this is 230, 126, and 34. So first we want our red channel to be 230. Then we want our green channel to be 126, and our blue channel to be 34. Cool. So that's how I'd access the function in my code. But what exactly is it supposed to do with that? Now, we know that this is how we set the color purple. With the R pin, we set a signal of 255. G pin, we set a signal of 0. And the B pin, we set a signal of 255. So we set the signal for each channel. And so we're just going to copy that code and do basically the same thing. You literally actually just copy this in. And instead of sending some predefined signal, we'll send this signal, which is our parameter. So we'll send red signal to the red pin, and then we'll send green signal to the green pin, and then we'll send blue signal to the blue pin. So now what I can do is I can set color, and I'll set it to this cool orange color over here. And I'll have it blink between this purple color and this orange color by just adding a little bit of a delay. So let's see this code in action and see what it looks like. So you'll see our purple LED turns purple, and then it turns to this orange color, which is very poorly represented in our simulator, but I don't blame them. Color science is difficult to do. Okay, cool. So now that we've got that set up, let's move into sort of explaining what a struct is. And it's very simple to sort of explain how a struct is. How do I save a color? Let's say I want to save a color. Let's say my friend gives me some color, and they give me this color over here, this nice blue color. And they're like, yeah, I want this color in my code. I want you to save it. Like, I want you to send this color between different parts of my code, or I want to access this color in different parts of my code. How would I save it? What I could do is I could do like int friend's color red equals, and then 31, and then friend's color blue or green equals. But this is tedious. It takes too much effort, and as programmers, we're really lazy, so we find shorthands or a way to shorten our code to make it more convenient for us. So what we're going to do is we're actually going to make something called a struct. And so a struct is basically a bundle of variables wrapped together in a nice little package. You can imagine Santa Claus got lazy, and instead of buying you like a PS5, he bought you all the individual components for a PS5 and wrapped it inside of one gift box, and you have to assemble it yourself. You just get every single component on the inside, but it's just in a nice little wrapping paper, so you can take it out and access only what you need, and it makes your life a lot easier. So let's make our struct. And so struct basically means structure. I think it's supposed to mean structure, but I just like to call it a struct. It's just fun to say. And so we're going to make a struct, and we're going to give it a name. And so we're going to give it the name color. So we made a struct, which is like struct is almost like a variable type. We gave it a name called color. Typically, you capitalize the first letter of a struct. And now we're going to add our code on the inside. So we can't really say like equals, because it doesn't really equal anything. It's a bundle of variables. So we're going to put some code on the inside to say what it's equal to. All right, cool. And so now that we have our struct color, we're going to add a semicolon, because never forget your semicolon. And also you need a semicolon to sort of terminate a struct definition. And what we're going to do is, let me explain this. Because we're defining a variable, just like the way that we do const int gpin equals 10, at the end of it, you either need a comma to define a new struct, or you need a semicolon to end that variable, or to define that variable. So we're going to make the struct, which is just another variable in our code. And what we're going to say is there's going to be 3 parts to this struct. We're going to have our red value inside of our struct, or an int red. We're going to have a green value inside of the struct, and a blue value inside of the struct. And so the way that works is we're basically bundling 3 variables, red, green, and blue, inside of one package called color. And this will make our life actually a lot easier, because what we can do is we can now define a new color. So color now becomes a variable type. And let's say I want to make a color, and my friend's color, I'll call this ocean blue. Very fancy. Now, I created this color ocean blue, but what I can do is I can actually assign its values, again, by sort of expanding it out into this code block, right, like this. And I can give it different values. So we know that this color is supposed to be 31, 97, 141. 31, 97, 141. So now we've defined our ocean blue struct, or ocean blue color, of the type. Okay, so our variable ocean blue of the type color, which is a struct that contains these variables inside of a bundle. And so we use these curly braces to expand the definition, or curly braces almost looks like the gift wrapping, or that paper around your variable, to package multiple ones together. So we can package multiple variables together over here. And what we can do is now we can make a new function, and we'll call this void set struct color. And so now we only have one parameter where we have our color C. We'll call it our color C. So we only have one parameter that we're going to input, and it's going to be our color C. And we're just going to copy this code over here, because it's just easier to copy code. What we're going to do is, instead of setting it to red, because red is not a parameter, we can set it to C dot red. Now, what does C dot red mean? Well, because we put our variable inside of a gift wrapping, what we want to do is we want to sort of expand this gift wrapping, and we want to access the different parts that are inside. So let's go back to the example of I wrapped the PS5 inside of gift wrapping. If I want to access just the controller, what I can do is I can say I can tear apart all the wrapping and I can take out the controller, but then I'll have a whole mess. So I can use the dot operator to almost pull it out of there, just to get that one specific thing that I'm looking for. And so the dot operator will access an attribute of your struct. An attribute is one of these variables on the inside, so it'll access one of the variables on the inside. So we know that for our struct color, one of the attributes is red, or one of the variables on the inside is red. So we can do color.red to just get that red variable. Or we could do color.green. Or we can do color.blue. Very cool, very nifty. And so with that, what we can do inside of our function over here is we can say c.red, or c.green, or c.blue, which will basically set our struct color to whatever is inside of this color variable that we set over here. So now let's put that into use. What I will do is I will say set struct color, and let's give it our color ocean blue that we just defined. And then we'll add another delay of 1,000 milliseconds. Now, if we see our code, we should see that our error variable or field set struct declared void. Color was not declared in this scope. Oh, wait, sorry. Did I mess up this definition over here? Yeah, you write the type, you write the word color so much that you get bored of it. Okay, 1 second. Oh, right, thank you for coming back with me. So, you can ignore this tab over here. Turns out all of my syntax was right. I just completely forgot. So, one thing that I think we may have iterated in some of the previous tutorials, Arduino works off of C++, but a very old version of C++. So you'll see a lot of C++ conventions available in Arduino, but it also has some of the older C conventions. And so one of the C conventions is going to be the fact that you can't access color as a variable immediately, especially in your parameters. What you have to do is you first have to define the fact that it is a struct. So you have to say, oh, yo, this is a struct, and then say the struct type, and then say the variable. So you have to add the struct, and then your sort of struct name, and then your struct variable. So yeah, if you see over here, our code will actually work pretty well. So you'll see that it'll, work actually perfectly. So I'll switch to yellow, and then I'll switch to our ocean blue color, which is, again, very poorly represented in the color science of this, which is perfect. So we kind of have this sort of idea of structs, and we have this idea of like how we can use functions to make our code shorter, because look, we just condensed this to one line. But we can also combine all of these ideas together now, and we can make something that's almost like an object or shorthand for our entire RGB LED. And so let's do that. So we're going to make a struct, and we're going to make a struct for our entire RGB LED. And so what variables are important for an RGB LED? Well, first we need to know all of our pins. So our R pin, our G pin, and our B pin. So int R pin, G pin, B pin. All of those should be defined. And then what we're going to do is we also need to define, we also need to define sort of, not a default color, but we need to start defining the struct itself. And so what do I mean by defining the struct itself? Well, for simple variables like this, it's easy to initialize by just, packaging the variables together in a bundle. But we can actually add functions on the inside of a struct because of the new C++ conventions. And so one of the functions we can add on the inside of the struct is, we could call it like our RGB LED Constructor. So we could say RGB LED over here. And so the way this will work is whenever I make a new RGB LED, I can initialize it with these brackets now, almost like it's a function. And so I can now add my parameters over here. Well, I need my R pin, so I'll call this my red pin, and green pin, and blue pin. So what we can do is we can say R pin equals red pin, G pin equals green pin, B pin equals blue pin. And so this is just a function, just like this. But what we're doing is we're basically going to be setting the variables on the inside of the struct by constructing it. So how would this look like on the outside? I think that's the more important question. What we can do is we can now make an RGB LED, and we'll call this my LED. And I can initialize it like this. So instead of using graphing paper like this, I can initialize it with this function like this. So now I can say, well, we know our pins are 11, 10, and 9, so I'll just do 11, 10, and 9. And the benefit of doing this is that now we can add more functionality inside of initializing it, because we know that when we're initializing our variable, we also need to do the setup over here. So we'll say pin mode, and we know that the pin mode is supposed to be rpin output. Pin mode. And we know that gpin is supposed to be output. And then we know pin mode. Bpin is supposed to be output. Right? And so now that we've done that, what else we can do, or what we can do beyond that, is we can start making a function for like set color. So first we do the return type. Oh, one thing you'll notice here, the return type is the struct itself, which is why this works out over here. So we might need to add the struct keyword here before this. We'll just check by debugging our code later. We're going like pure programming experience here. But now let's do one for set color. And we're going to set this for our struct. So struct color C. And we've already written this code elsewhere. So what we can do is we can just sort of copy this over here. Or actually, no, we can just copy this over here because this matches our convention. And bada bing, bada boom. C.add, C.green, and C.blue, which is going to be our color, red, green, and blue channels respectively. And so now, what we can do instead of all of this is we can sort of delete this code over here. We can delete this code up here because we don't really need it. We just need this color struct over here. We can remove our setup for these pins as well because we're going to be setting it up elsewhere. And let's try running this code. What we might have to do is we might have to set up this inside of the setup function once instead of doing it outside like this. It really depends on how Arduino will treat our code. But this is sort of, the more fun debugging side of it. But what we can do here is we can do myLED dot, because again, we're going to use a dot operator to access the functions on the inside, just like we access the variables, because a function is basically a variable, or it's a type of variable. And then we're going to set this to our ocean blue color. Let's see if this works. Never be scared of errors, I say. Never be scared of errors. But we see that it actually does work. Yay! Hip hip hooray! So we see that our RGB LED over here, with these three there are actually 5 variables on the inside. So there's going to be this rpin variable, this gpin variable, this bpin variable, an RGB LED constructor variable. So this is called a constructor because it makes our RGB LED, which we see in action over here. And our set color variable, which is a function that'll take in a color C, a struct color C, and it'll display an LED color like that. And so this is just one way that if you have custom components or components that don't have, like easy to use interfaces for them, like the servo library we used from the last time, this is how you can make your own version of it, especially if you mix multiple things together. So it's really useful to sort of shorthand your code. Let's say you have multiple RGB LEDs. Now you can, here look, we can initialize a second RGB LED over here. And what we can do is we can fire this up very quickly. Common connects to ground, and our G connects to 5. Yep. And our B connects to 3. But what we can do is, instead of doing all of that, we can call this our second LED, and we initialize this with 6, 5, 3, which I think are the pins, and we have to go into our diagram.json and set up this attribute over here. Cathode. Perfect. And then let's head into this section over here, and let's turn on our second LED to display a new color. Set color. Let's set our new color, and let's make a new color over here. Color. I like this green color. We'll call this leaf green, 35, 155, 86. If you couldn't tell, I'm a Pokemon fan. 35, 155, 86. 86. And you'll see that once we set that up, we can actually set this to display leaf green color. And let's see how that goes. So you'll see that one LED is our ocean blue and the other is the leaf green. Now you can't tell the difference because the color science on these is so bad. But yeah, so this is how you can display different sort of colors, and this is how you can use a struct to make your code shorter and modular for new components. We will have a basic problem and a challenge problem after this, so you can sort of enhance your learning. But I hope this did help in sort of understanding. To review or recap our sort of topics, a function, such as this one demonstrated over here, is very simply first the return type, the name of the function, the parameters or the different variables that are used inside of the function, and the code for the function itself. A struct is a special type of variable, just like an int variable that you see over here, but we've bundled them all together with these curly braces, and we give it a name. And so we can access that name inside of our variables like this, or inside of our functions like this, or just as normal variables like this, and you can initialize them by adding some gift wrapping around the package. Or in the case of this RGB LED over here, because we can't add gift wrapping around function packages, what we're going to do is we're going to use an initializer, which returns, so again, the function return type is just this RGB LED, and the name is also RGB LED, so it has both. And then these are the parameters, and this is the code to initialize it. If you have any questions, please let me know. I hope this was clear. Any feedback is really appreciated, and I hope this helps you out in your future Arduino projects. Thanks for listening in.